Welcome to David Alexander Maths Tuition. This is chapter 6A on sec, cosec and cot. Okay, so what is cosec, sec and cot? Well, the cosec of x is 1 divided by the sine of x, or 1 over sine x. Sec x is 1 over cos x, and cot x is 1 over tan x. If you ever get a little bit confused, then just remember it's the third letter. It corresponds to the first letter of the functions that we're kind of familiar with. So for example, cosec s, so that's 1 over sine. Sec is, well, obviously the third letter of sec is c, so that's 1 over cos, and cot t tan x. I do find that some people might think that the sec x is 1 over sine x because they both begin with an s, or that cos and cosec are somehow linked, but that's not the case. So cosec is 1 over sine, sec 1 over cos, and cot 1 over tan. Just remember that. Okay, so here are some relatively easy questions. It's just a bit of calculator work. So what is the sec of 250? Well, that is 1 divided by the cos of 250. So that is negative 2.92. The cosec of 150 is 1 over the sine of 150 degrees, and that is therefore 2. The cot of 132 degrees is 1 over the tan of 132 degrees, and that is negative 0.9. I'm just rounding kind of randomly at the moment. Cosec of 7 pi over 3, that is 1 over the sine of 7 pi over 3. Note that it's 1 over the sine of 7 pi over 3. It's not the sine of 3 over 7 pi or anything like that. And for this we will get 2 root 3 over 3. The sec of 2.8 radians is 1 over cos 2.8 radians. So obviously for the cosec 7 pi over 3, I've changed from degrees into radians here. So the first three, these are in degrees, and these ones here are in radians. And 1 divided by the cos of 2.8 radians is negative 1.06. And cot of 11 pi over 10, that's the same as 1 over the tan of 11 pi over 10. Again, it's not the tan of 10 over 11 pi or anything like that. So that is 3.078. Okay, what I tend to do with these is I would work out, say for the first one, right, just type into my calculator, cos 250 equals whatever, and then just do 1 divide by answer equals, but I mean, it doesn't really matter. Just find setting up fractions and having to do all the brackets with the angles a bit of a pain. Just my particular shortcut, but you know, you can do it any way you like, obviously, as long as you're arriving at the correct answers. Okay, so for some of these questions we can rely on the triangles rather than the calculator, but of course you're going to be much more comfortable using a calculator. I get it. Right, so let's just take a look at a triangle where we've got a right angled triangle. This side length is 1, the hypotenuse is 2, and this is the root 3. So here we have our 60-degree angle, and here we have our 30-degree angle, or in terms of, if it's in radians, that could be pi over 6, and down here that could be pi over 3. So again, we know, for example, we can work out that the tan of 60, that is going to be root 3 over 1, so root 3. So therefore from that we can work out that the cot of 60 is 1 over root 3, or root 3 over 3. So we can use this triangle not only for sine, cos and tan, but also for sec, cosec and cot. Let's just pick another one at random. If I wanted to work out the cosec of pi over 6, so I know that that is 1 over the sine of pi over 6. So here I'm working in radians. So that is 1 over, so the sine of pi over 6, here's my pi over 6, that's 1 divided by 2. So 1 divided by a half. So therefore the cosec of pi over 6 is 2. So again, I like using the triangles quite a lot for my 60-degree, 30-degree and my 45-degree. I actually find it quicker than using a triangle, but I've been doing maths probably a bit longer than you. But you know, it's maybe something to aim towards. I just find it just a lot less hassle, really. Okay, and here is my triangle for the 45 degrees. So this is side length 1, this is side length 1, and the hypotenuse is root 2. So this angle here is 45 degrees, or pi over 4. So if we wanted to work out, let's say, the sec of 45 degrees, we need to remember that that is 1 over the cos of 45 degrees. So that is 1 over, now the cos of 45 degrees is adjacent over hypotenuse, so that's 1 divided by 1 over root 2. So that is simply root 2. There we go. So again, using our triangles, we can work out the cos, sine and tan of angles, and then just do 1 over whatever that is to get your sec, cosec and cot. Okay, prove that cot pi over 4 plus sec 5 pi over 3 equals 3. Okay, so what's the cot of pi over 4? So here is my triangle, 1, 1, root 2. So I know that the tan of pi over 4, here's my pi over 4, is 1 divided by 1, which is 1. So therefore the cot of pi over 4 is 1 over 1, which is still 1. So that is 1 plus the sec of 5 pi over 3. Well, first of all, what is the cos of 5 pi over 3? So I'm going to use my cast diagram here, CAS. I mean, I could cheat and just use my calculator. So 5 pi over 3 to go all the way around to here, that would be 1 pi, what am I talking about? All the way around would be 2 pi, which would be 6 pi over 3. So if I'm just going around 5 pi over 3, let me just draw that again. It's a bit unclear. If I'm measuring from here, then 5 pi over 3 would take me that far round, more or less, leaving an angle here of pi over 3. Okay, so this is in the C quadrant, so cos is still positive. So the cos of 5 pi over 3, that is the same as the positive cos of pi over 3. Okay, so what is the cos of pi over 3? So let's just do our 1, 2, root 3. So pi over 3, or if you're still thinking of this in degrees, pi over 3, that is your 60 degrees to this one here. So the cos of pi over 3 is 1/2. So the cos of 5 pi over 3 is also 1/2. So the sec of 5 pi over 3 is 1 over 1/2, and 1 divided by 1/2 is 2. And of course, 1 plus 2 is 3. Okay, let's take a look at the next one. So what I'm going to do is I'm going to work out the sine of 3 pi over 4. Again, you can cheat and just grab your calculator, but let's use our cast diagram, CAST. So that's 3/4 pi. So pi is half a term, so we're going just shy of that and creating this angle here, which is pi over 4, and that is in the S quadrant, so it's still positive. So the sine of 3 pi over 4, that's the same as the sine of pi over 4, not negative sine pi over 4. And now we can just do our triangle, 1, 1, root 2. The sine of pi over 4 is 1 over root 2. Okay, and the sine of 3 pi over 4 is also 1 over root 2. So we want the cosec, which is this flipped, so that is going to be the root 2. Okay, right, let's take a look at the sec of 2 pi over 3. So first of all, I want to work out the cos of 2 pi over 3. So again, kind of running out of space here, CAST. Again, a lot of this can be done on a calculator. So 2 pi over 3 will create this angle here, which is 1 pi over 3, and that is in the S quadrant, so cos is negative. So the cos of 2 pi over 3, that is the same as the negative cos of pi over 3. Right, let's just randomly do our triangle here, shall we? So that's 1, 2, root 3, and pi over 3 is this angle here. So the cos of pi over 3 is 1/2. So the negative cos of pi over 3 is minus 1/2. So the cos of 2 pi over 3 is the same as negative cos of pi over 3, which is negative 1/2. Now we want the sec of 2 pi over 3, which is 1 over 1/2, and 1 over negative 1/2. And 1 divided by 1/2 is 2, so 1 divided by negative 1/2 is positive 2. So we want to subtract negative 2, and minus 2 is plus 2. So we've got root 2 plus 2, which is the same as 2 plus root 2. So a bit of a fiddle, that one. Again, what you're going to do realistically, you're just going to type into your calculator tan pi over 4. What is 1 over that? what is the cos of 5 pi over 3? What is 1 over that? Just use your calculator a bit more rather than using the cast diagrams and the triangles, which, some students, they don't find them confusing. They're just not in the habit of using them, so therefore prefer just to hit the calculator straight away.